Okay, today we will start with unit 3, which is electrochemistry. So from the name electrochemistry you can see there are two parts, electro and chemistry. Electro means connected to electricity and chemistry means we'll think about chemical reactions. So there is a connection between these two things, electricity and chemical reactions. So what is the connection between these two? The connection between these two is we can use these chemical reactions to produce electricity. We can use, I'm repeating again, we can use chemical reactions to produce electricity, or we can use electricity to start chemical reactions. We can use this to start chemical reactions. Either way it works. So which type of chemical reactions can we start? Those chemical reactions which are non-spontaneous. Non-spontaneous means which do not occur spontaneous, which do not occur on their own. They require an external agency to start the reaction. So the external agency in this case is going to be electricity. So it works both ways. Either we take a chemical reaction and produce electricity, or we use electricity to start a chemical reaction and produce some other chemicals from here. That is the study in electrochemistry. So you will see that when I asked you to mark from the textbook this portion, first page, so you can see I have given you the definition. What is electrochemistry? It is the study of the production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to bring about non-spontaneous chemical transformations. So this is what I have explained just now. And what is the use? Why do we want to study this electrochemistry? Why do we want to do anything related between electricity and chemical reactions? Is because we can use them to make batteries and fuel cells. What do they do out there? They convert chemical energy into electrical energy and are used on a large scale in various instruments and devices. So this part I have explained. Then you can see we are taking up a particular reaction, and this was done by Daniel. So it is called a Daniel cell, and this converts the chemical energy liberated during a reaction between zinc and copper. Zinc solid, but copper may be in the form of copper sulfate. Zinc and copper sulfate, it produces zinc sulfate and copper. Zinc sulfate has been written in this way. So let me just explain to you this particular thing. This is what is present in the normal batteries which you are using for your remotes, or for running your clocks, or for any other thing. The Daniel cell is present inside those batteries. So these type of batteries, we will not call them batteries when we study them. We will call them electrochemical cells. So let us see what is a redox reaction first of all. So you have done in class 11, but just to refresh your memories, let me just do this. So Daniel cell is a reaction between zinc solid and copper sulfate, where we write it in this way, striking of the sulfate. What does it produce? It produces zinc sulfate and copper solid. So now how does this reaction occur? So actually, for doing this particular reaction, you can see in the textbook there is a figure like this, where there is one container which is a solution containing salt of zinc, maybe zinc sulfate, and a zinc rod is dipped in that zinc sulfate, and you have another solution out here in another separate beaker, where this is a solution containing any salt of copper, so it may be copper sulfate, which is here, and a copper rod is dipped in it, and they are connected through an electrical wire. So to maintain the flow of electrons through this, because the two beakers are separate, we are putting something called a salt bridge. So if any electrons means electricity, if it is coming out, this maintains the flow of electrons. So let us see what is happening separately in this container and separately in this container. So if I draw the figure and write everything, so this is zinc sulfate, and in this is dipped my zinc rod. Then I have another container where I have this solution of copper sulfate. So in this one I have copper uh, mm, rod dipped in it, and these are connected by a battery, by a electrical source. And to maintain the electrical flow, we have the flow of electrons, we have our Sol bridge. This is what is drawn in your textbook. So now something is happening in this part, and separately something is happening in this part, because of which electricity is being produced. So let us see what exactly is happening. So this type of a setup is called a electrochemical cell, or galvanic cell, or voltaic cell, after the name of a person called voltaic cell. These are the different names. Or in this specific example which we are taking, this is called a Daniell cell. It's called a Daniell cell. So since he has done it, so we'll see what is happening separately in these two containers. Separately something happens. So zinc sulfate will is combined with zinc rod, and remember, copper sulfate is in combination with copper rod. These two things you have to remember. So now let us see what is happening when we are putting copper sulfate. We write aqueous because we are making a solution. So this will break down to give you Cu2 plus and SO4 2 minus. So inside out here we will be having, this will break up and it will give you Cu2 plus and SO4 2 minus inside this solution. So lot of them are there, and aqueous. So nothing happens to the sulfate. We'll talk about this later. We are more interested in what is happening to Cu2 plus in this solution. So Cu2 plus, I write aqueous. It will pick up electrons from this rod, because you can see it is connected to the negative portion of the electrical source. So electrons will flow from here, and there will be lot of electrons out here. So this is going to, because 2 positive, at least 2 electrons it picks up, and it is going to get converted into copper solid. So this is what happens in this particular part of the electrochemical cell. So whenever we add electrons, you know this is reduction. So that's why this is called a reduction half cell. This is called a reduction half cell. Reduction half cell. Half cell, why? Because 2 together will make up the full cell. So half part of this is this container. So that's why reduction half cell. Now let us see then what is happening out here. So that means Cu2 plus from here is picking up 2 electrons and becoming copper. So the rod will get fatter and fatter, because copper will be, solid copper is going to get deposited out here from copper sulfate into this copper rod. So more and more copper will get deposited out here. So since it is picking up 2 electrons from here, so there is a deficiency from the other side. So what will happen? This will supply it. So the next reaction, so just like copper sulfate is breaking down out here, zinc sulfate will also break down to Zn2 plus and SO4 2 minus as soon as we put them in the solution. So zinc sulfate also breaks down to give you Zn2 plus and SO4 2 minus in this water aqueous medium. So again we concentrate on Zn2 plus. So Zn2 plus aqueous will actually is the thing which is giving out 2 electrons. So from here this zinc rod, zinc will give out 2 electrons which will move through the wire, and this will come down and produce more and more Zn2 plus. So this rod will grow fatter and this rod will grow thinner and thinner, it will totally fade away. It will fall off from here. So this is what is happening. It is going to give you, Zn solid will give you, Zn solid is going to give you Zn2 plus 2 electrons. So if I write it in this order, then it becomes Zns minus 2 electrons will give you Zn2 plus. So this will be in aqueous. So Zn is depositing down there as Zn2 plus. So now you can see it is minus 2 electrons. So this is called oxidation. So that's why this cell is called the oxidation half cell. So this is oxidation half cell. So here oxidation is occurring and here reduction is occurring. If this doesn't work, this doesn't work. If this doesn't work, then this will not work. Both of them are working at the same time. So our important two reactions are this reaction and this reaction. So two things are occurring simultaneously. So that means the sum total of this, when we take these two, we get this reaction which is on top out here. You can see Zn2 plus 2 electrons and 2 electrons will get cancelled, and Zns plus Cu2 plus aqueous will give you Zn2 plus aqueous plus Cus. So we get our final equation. So this is what is happening in the Daniell cell. Two half reactions. Here one side this is occurring and in the other side that is occurring. So you get your electrochemical cell. So this is one half cell. This is another half cell. So I think in the textbook you have underlined, you have noted down. So you can see here Daniell cell, the final reaction has been given and then the two reactions are given. This is called reduction half cell and oxidation half cell. These reactions occur in two different portions of the Daniell cell. The reduction half cell occurs on the copper electrode, while the oxidation half reaction occurs on the zinc electrode. These two portions of the cell are also called half cells or called redox couples. The copper electrode may be called the reduction half cell and the zinc electrode the oxidation half cell. Then from here, what other things are there of importance for us to know? A potential difference will develop between the electrode and the electrolyte, which is called the electrode potential. When the concentrations of the species involved in a half cell is unity, means suppose I prepare a 1 molar solution or 1 molar solution here also, the potential that is developed between the electrode and the electrolyte, that is called electrode potential. And if you take the concentrations to be unity, say 1 molar or 1 molar, then the electrode potential is known as standard electrode potential. These are very, very important definitions, so you must learn them. Then in this type of cell, in a galvanic cell means just now the cell that we have done, that is a galvanic cell. The half cell in which oxidation takes place is called the anode. So now we have done out here. So we see the zinc becoming Zn2 plus, their oxidation is occurring. So this will be called the anode. This is called the anode. And this one where reduction is occurring, this will be called the cathode. So this portion, this electrode is called the cathode. So you can see here, I have to ask you to underline. In a galvanic cell, the half cell in which oxidation takes place is called anode and it has a negative potential with respect to the solution. The other half cell in which reduction takes place is called cathode and it has a positive potential with respect to the solution. Thus, there exists a potential difference between the two electrodes. As soon as the switch is on, is in the on position, the electrons flow from negative electrode to positive electrode. So here you can see, if this is the anode and this is the cathode, so anode is the negative electrode and cathode is the positive electrode. So from here to here electrons, and I think you can see very well zinc is giving out electrons, so these two electrons are flowing from here to this side. So because of one electrons going from one side to another side, a potential difference is generated between this side and this side. So that is how the galvanic cell is working. Then how do we represent them? How do we represent them? That is given in a more elaborate way. The potential difference between the two electrodes of a galvanic cell is called the cell potential and is measured in volts. So you have to be very careful in understanding. The potential difference between electrode and the electrolyte is called electrode potential, but the potential difference between one side and another side is called cell potential. Please know the difference between electrode and electrolyte is called electrode potential. Two different things you are learning. That means inside one part, either here or there, in both places you have electrode potential. Between two electrodes, what do we mean two electrodes? We are seeing this is one electrode and this is one electrode. Between these two, this is called cell potential. So two different things, please remember them. Between electrode and electrolyte is electrode potential, between two electrodes is cell potential. So you can see in the textbook, and it is measured in volts. Obviously electricity is measured in terms of volts. So the definition is here. The cell potential is the difference between the electrode potential, the reduction potentials of the cathode and the anode. And what is it called? The cell potential is called the cell electromotive force, or EMF, of the cell when no current is drawn through the cell. Just because they are moving from here to there, whatever this is giving out, the other is taking. So no current is actually flowing through the cell. So it is called cell electromotive force, or EMF. And by convention, we keep anode on the left and cathode on the right while representing the galvanic cell. This is very, very important for you to note. When we draw this also, when we draw this, the left side one is always the anode and the right side one is always the cathode. Then representation I will explain to you a little later, more elaborately. You just remember, on the left is anode and right side is cathode. So regarding vertical line, I am going to explain a little later about double vertical line also. But you just remember to calculate the EMF of the cell. E cell is given by E right minus E left. Whatever potential I am measuring from here, that means E right minus E left, whatever difference comes out from this, that only is nothing but your E cell, or EMF of the cell. So some examples are given here. You can just see, if you have a cell between CUS and Ag plus, then this is the reaction. Half cells you write like this, then from there this is the way we write. So we will see, since oxidation is in copper one, so we write copper first and then we write for silver, because silver is cathode. So anode and then cathode, and the double line represents the salt bridge, and E cell is given by E right minus E left. So what is on the right? Silver, and what is on the left is copper. Then you can see for this Daniell cell it has been done. Same thing again, whatever we have done. Zinc giving you Zn2 plus, so 2 electrons, and Cu2 plus giving you Cus. So that will be, this will become your left because it is oxidation, and this will become your right because it is reduction. So this is your anode and this is your cathode. So E0 cell, EMF of the cell is given by E0 right minus E0 left. They have calculated for this much, it is coming 0.34, and for the other one it is coming minus 0.76. So minus of minus that, so it is 1.10 volts. You can have a look at your batteries. You will find there this is written there in the battery. From the battery the output is 1.1 volts. You can see those A type of batteries, A batteries you are using at home. All in the batteries you will find, in all batteries it is written 1.1 volts. So this is the calculation for that 1.1 volts.